All right, in section 4.2.2, we'll be talking about projections in an inner product space. So here's the projection theorem. Let V be an inner product space. Let W be a finite dimensional subspace of V. Then for any U in V, there is a unique W in W and X in W perp, so that U equals W plus X. All right, here's the picture. I have a subspace W. I have its orthogonal complement. So I can split up V like we did before is with one part W on W and one part X, which actually is on W perp. All right, so orthogonal projection, let's define this. This element W is called the orthogonal projection of U onto W, and we write W equals the projection onto the big W of the element U. And one thing that's interesting here, so we defined this W to be the projection on W. This X is also a projection, it's just a projection on W perp. All right, so let's find a formula for this projection so that we can actually compute it. So let W be a finite dimensional subspace of V. Take U in V. I'm going to assume that I have an orthogonal basis for W, so BW is an orthogonal basis for W. Then the projection is going to be computed using the inner product. So it's going to be U dot the first element, V1, V1, and I'm going to multiply that real number by V1. All right, so this is familiar. That's the classic formula for a projection, but now we're going to add a bunch of terms, one for each dimension of my subspace. So this is VK, VK, VK. All right, so this is going to be my projection onto W. All right, so let's prove this. I'm going to take U equals W plus X again. I'm going to assume that W is in W and X is in W perp, as in the projection theorem right here. All right, W's in W, so I can use the basis to write it, the basis BW right here. And in fact, by the theorem 4.2. I want to say 2, but let's see, 4.2.2 exactly. By theorem 4.2.2, W is WV1, V1, V1, plus W VK, 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 VK. So I'm applying this theorem to W with this basis on little w, and what I'm getting is I'm getting something close to what I want. The only difference is I have W here instead of U. All right, so let's check how that differs. If I take U dot VI, that's W plus X dot VI. So that is W VI plus X VI. All right, so this is what I have here. This is what I have part of my formula. I don't want this to be the formula because I'm trying to get W. I don't want a W in the formula to get W. That would be useless. So I want to use U instead. U is made up of two parts, but X is perpendicular to anything in W, and VI is in W. And so that part is 0. And so I do get that whether I want to use V or W, they will give me the same answer. And so projection on W of U, that is little w, I can use U instead of W in the numerator of these numbers. And we have our formula for projections. All right, in the next video, we'll be using this formula on an example.